Today, we're going to be talking about queues. Now, what the hell is a queue? What even is that? So basically, it's an abstract data type, okay, an ADT that follows the first in, first out principle, right? Say you have let's say you have like a bunch of guys, right, in a line. First guy that went into the line will be the first guy that goes out of the line, right? And as you put guys in, they go to the back of the line, right? And the first one that you're going to take out is the guy in the front. Okay, so for example, let's say we want to remove this guy. Now this guy is in the very front. Okay, elements are added at the back and then removed from the very front, similar to a real world queue, right? You're waiting in line at the cash register or something like that. All right, so some of your basic operations, right? Okay, so you got on queue. Let me just take a sec to write this. You got dequeue. You got front. You got is empty. And you have size. Now let's just go ahead and start with on queue. What does on queue do? So on queue inserts an element at the very back of the queue, right? Say you have a queue of 5 guys. Okay, that's 5 guys. You want to on queue something into this queue, right? You're gonna put him at the very back. So I want to add like a red guy. Okay, I want to on queue a red guy into this queue. I would just stick him in the back, and there we go. Now next is dequeue. So you're going to be removing and returning something at the very front of the queue. So you don't always have to return it, but if it specifies, and this is typically what happens. So whenever you dequeue something, you're going to remove the very front guy, right? And typically what it means by return is a dequeue would be a function and it would return the actual guy itself, right? For example, if I had a list of like numbers, right? So say this is 1, this is 7,
and a bunch of arbitrary numbers, right?
If I dequeued this queue, I would be removing this number or this guy, right? And then returning 6. So that gets sent back to whoever called it. Now next is front. It's the exact same thing as dequeue, except you're not removing the front guy. You're literally just returning it, right? So in this case, it would be 2. Is empty. It checks if the list is empty or not. Obviously, this queue is not empty. It has 5 guys in it, so it would return false. Like typically this is a function with a return type of boolean, which is a true or false variable, but if you had a queue, let's say, that had no items in it, it would return true, right? Because it's empty, obviously. And then the last one is size, which returns the size, typically an integer, of your queue, right? Typically you would just keep track of the size yourself, or you could calculate it, but it would be best to just keep some kind of integer size in the class that you're creating this abstract data type in, and then incrementing the size whenever you on queue something, and whenever you dequeue something, you just decrement the size. Okay, so those are the basic operations, and now let's talk about how it is typically implemented, right? So these examples are all in C++. So queues can be implemented in many different ways, but typically they are in arrays. You could do it in a linked list, and these can include either doubly or singly linked lists. And the last is just using a queue from a standard library like standard queue from the C++ standard library. But for this example, we're going to go ahead and implement it as a singly linked list while keeping track of the tail. So let's go ahead and jump into implementation using a linked list. So I went ahead and opened VS Code and just created a random folder, and we're just going to make a main.cpp file. This is just where we're going to be doing the operations on the queue. All right, and now I'm going to make a header file for our queue itself where we're going to implement it. That's where our class is going to lie, all the definitions. So let's just create that file. We're just going to call it queue.h. All right, so in our queue.h file, we're going to go ahead and set up our struct first for a node because we're using a singly linked list. So let's just say struct node, right? We're going to go ahead and add in our data variable. and we're going to have a pointer that points to the next node, right? We're just going to be using integers to make things simple, but you can use template classes as well to just add in whatever variable you want, whatever type you want. Let's also add a node constructor. So if someone passes in an integer and a pointer to a node, let's just say, go ahead and assign those. And then let's also just create an empty constructor for if we don't have anything passed in, and we can just add some default values here. So let's just say data equals 0 and next equals null pointer, right? Now let's just create our actual class for the queue. There's going to be public and private members. So let's just start with our private ones, right? Obviously we have our size, so that's going to be an integer. We also want a pointer to our head, and let's go ahead and add a pointer to our tail, right? In public, that's where all of our methods are going to go. So recall that we have onQueue, Dequeue, front is empty, and size. We're just going to start with our constructor here though, and I don't know how to spell. And we have our destructor. We have onQueue, which isn't going to return anything. So Dequeue, recall that it returns the front element after removing it. So let's just say it returns a pointer to a node, right? Front will also return a pointer to a node because it is the same thing, except it doesn't remove an element, and is empty. Obviously is going to be a Boolean because it's either true or false if it's empty. And then the size, let's just say give size, right? Because we don't want to name it the exact same as our size integer here. We're just going to be returning that integer. So there we go. That's our header file. And let's go ahead and implement these methods, right? So we're going to do that in a .cpp that's named the exact same as our header file. It's going to be queue.cpp. Right? Let's just go ahead and include our header file in here. And then I'm going to use namespace standard, but it's not always the best to do that, but it's most helpful in our case. So we're just going to go ahead and say our constructor. Let's see. So first we need to start out and make size 0, and we need our head and our tail to be null pointer. So we're just going to say size equals 0, head equals null pointer, tail equals null pointer, right? Now in our destructor, since this is a linked list, we're going to need to iterate through all of the elements and delete them one by one. At least that's what you would do with a normal linked list. With this, we're going to be implementing a dequeue function that just removes an element from the front of the list, if you can recall. So we can just use that until the list is empty, right? So let's just go ahead and implement that later. We'll come back to this, right? And then let's just get started with onQueue. Okay, so obviously onQueue is going to have a variable inside of it because that's what we're passing into it. That's what we want to onQueue into our list. And we want to make that void. We don't want it to return anything because we don't really care. The very first thing we need to do here is check if our current list is empty, right? So the easiest way to do that is to check if our head is equal to null pointer. And if so, that means the list is empty. So let's just go ahead and create our new node here, right? Equals new node. And here we can just say head equals new node. The tail equals new node. And we're going to increment our size, right? And we just need a return. Now, after this, it becomes super, super easy, right? Because if they've passed this if statement, if that is false, then that means there's at least one item in the list. But all we really care about is inserting something before the head. Like, recall how that actually works. So if we're inserting something at the head, we just put it before it, right? We say our new node's next pointer is going to be the current head of the list. So for example, right, our next pointer is at the head, and you can see the head is still pointed to that second item, but all we have to do is update it to our new node, right? So now our head is at the very front of the list, or I guess back, you could say, in terms of a queue. So we can just say new node next is equal to our head, and our head is now our new node, right? But we don't want to forget to pass in data that we're inserting into this new node. Otherwise, it would just be 0 by default because we just, declared a new node right here. And as you can see before, our default constructor is going to set data to 0. We've also updated our next pointer here. And instead of being null pointer, it's going to be that second item in the list. All right, so now that's implemented. And let's go ahead and test it, right? So I'm just going to make a very basic print function. And let's just say void print here, and we're going to declare a current variable. So node start cur equals the head. And I've just included IO streams so that we can use cout, so that stuff will, go out into our terminal or console. And this basically just prints every item in the list, right? Until the current item that we're pointing towards is null pointer. So basically it'll print out the value of this one, and then this one,
And then this one, and then this one, and then this one.
and then this one until it goes here, which is obviously null pointer, right? So let's go back to our code and let's test this out, right? So let's go ahead and include our queue header file in main.cpp. And let's go ahead and do that correctly. Okay, we got to use quotes instead of angled, whatever these are. All right, so let's just go ahead and create a new queue. I'm just going to name it the letter Q. Let's just add the number 7 and the number 9. And let's say the number 13, right? And now let's print it and let's see what happens when we run our code, right? Let's just run /program. And there we go. I've printed out 13, 9, and 7 because every new item that gets added to the very front. So this is our actual order. Now, if we dequeue something, that would be removing 7, not 13. It's first in is the first out, right? Since 7 was the very first one in, that's the first one that gets kicked out once we dequeue it. So let's just go ahead and fix our print statement to have an end line there. And then let's just recompile these. All right, /program. There we go. It's on its own line. Okay, so now we know that our onQueue function works. Let's just go ahead and implement dequeue. So that's going to be returning a pointer to a node and has no arguments because it doesn't need any. And now the very first thing we have to do again is check if the list is empty. That's always have a base case, or in this case, just a case, right? Always make sure you're checking if the list is empty. So if the list is empty, we're just going to return because we don't really need to do anything. We don't need to remove any items from the queue. The next thing we're going to be checking is if head next is null pointer, which means if there's no second item, then all we have is one item, which is head, right? We're just going to create a new node pointer. It's the old head, right? And we're just going to go ahead and we're just going to say head equals null pointer, tail equals null pointer. Then we're going to return old head, right? Because we still need to return that value. All right, that's if one item was in the list. All right, next, all we're going to be doing is removing at the tail. Remember how this one works. If we have our list of 5 guys and we want to dequeue it, we're just going to be removing this guy. Okay, and this guy is the tail. So what we would need to do is iterate through our list until we get right before the tail and update this next pointer to be pointing towards null pointer instead of the tail, so that this basically gets knocked out of the list, and then we can just return the tail and then update the tail to be that new last item because we just removed this one. So here's what we're gonna do. We're gonna say node star cur equals head, or let's just say while cur next is not equal tail. This will essentially take our cur pointer to the item that's just before the tail, right? So 1, 2, 3, 4, right? It'll take us here if that is our tail. Mind my bad handwriting here, but so while cur next is not equal tail, we're just going to say cur equals cur next, and that's going to take us all the way right before our tail. Then we can say cur next equals null pointer, and I'm going to go ahead and create another pointer for our old tail, right? And then we're going to say tail equals cur equals our new item that is right before the tail. That is our new tail, since we're removing that last item. Now we're just going to go ahead and return old tail, right? Now this should work. So let's go ahead and test this out. We're going to say q.dequeue. And when we print this out, it should, in theory, only print out 9 and 13, or I guess 13 and 9 in that order. So we're just going to add another print statement here. All right, so let's go ahead and recompile. Okay, I forgot a return right here. So let's just return null pointer. Okay, and then recompile once more. All right, it successfully worked. It printed out our full list, and then we dequeued one from the list. It removed the very front. It removed 7. So now we just have 13 and 9. And if we dequeue again, it should, in theory, remove 9. All right, then we'll only have 13 left. So let's just do that one more time. There we go. Now we only have 13. So now we successfully have our queue and dequeue functions implemented. That's basically the very hardest of all of our methods. Queue is not very hard to implement, right? It's a pretty simple abstract data structure. It's just understanding the fundamentals behind it and how inserting and deleting works, essentially, right? Remember, it's first in, first out. So this element right here would have been the very first thing that was on queued or inserted, right? And it'll also be the very first thing that gets dequeued once we call a dequeue method. So let's just go ahead and implement the rest of these. These are going to be pretty easy. Next is front. So we can take a lot from our dequeue method. So all we literally have to do is return the tail. And that would mean that's the very front of the list. So this is our tail, remember? And if we call front, it literally just returns that. All right, so now we can do whatever we want with the value of tail. All we need is return tail, right? Super simple. Next is empty. We've been checking if our list is empty the entire time, so this is going to be pretty easy. We just return if the head is equal to null pointer, right? If our head is equal to null pointer, then our list is empty. All right, and let's go back to our dequeue and let's just go ahead and add our size decrement stuff, right? We'll say size minus minus there. We'll say size minus minus there. Okay. Cannot forget the size. Now, finally, we have our give size method, which is going to be another very, very simple one. That's just returning the size, right? And that is about it. Queues are pretty simple. It works just like a line. You have a bunch of guys in your line with a pointer to the next guy and pointers towards your head and your tail. And that's about it. Remember, first in, first out. That's literally what this is all about. First in, that's literally all you need.